I can't. Cyber Bob beat Mad by about a half a second. Not your third 3D medic. Close. Come on. Processor. Sky, moon, stars, ceiling fan, some dead bugs in the ceiling fan, and I finally got the first prototype of the flashlight built. It's fucking huge. it's a little on the big side, but it is finished. It works. First thing we gotta do is get rid of that switch. It's way too big. It's massive overkill, and I ran into some problems that are actually a pretty big problem. The where is that little bag? Here it is. Turns out these are not the same as the ones I got the first time. The wires on this second batch that I got are significantly thinner than the wires on the first batch that I got. And so when I ran out of the first ones, I started using these, and I quickly ran into a problem where when I plug this in to charge it, the wires start heating up because this is capable of charging at 25 watts. And the first set of wires, no problem, they don't heat up at all. These, there's not enough copper or aluminum in there, so they can't. No, they're handling it, but they can't properly handle the 25-watt load that the BMS is capable of absorbing. And so I gotta figure that out. You see, I got the copper heatsink in there, so we'll never have to worry about that overheating. The battery is absolutely freaking monstrous. Let me find the other battery to show you. That's the battery. So it's a single cell 20 amp hour 64 watt hour battery. So that will run that light for a very, very long time. Good morning, Big Bad Joe. And if we run it at 4 watts, that should run that flashlight for 15 hours. And if I put a low mode, a Firefly mode in there, like a quarter watt, that'll run it for 200 hours, which would be like what, 8 days? You know, that was the idea, you know, a 1 week runtime. So you can either get, you know, a little over half a day at full brightness, or a week at low brightness. Right now, this is just hooked up at low because these are a freaking pain in the ass to solder. Not yet. Although I do have a couple. Well, I think the aluminum plates won't be here until like the 15th. At least that's what it said if I were to buy it. And I know you got me the samples. Thank you. They might be waiting for me at the post office. So I know I got a notification. I got like 4 packages at the post office. So I'll go by today and get those. Thank you very much. But this does work. It's weird though. For some reason, both of these first two are connected to positive. Why have them then? I mean, they must serve another purpose, but you know, I wired it up and it works. I'm able to turn the pot and adjust the brightness. I kept getting an intermittent connection. It would keep turning off. It's because it's a pain in the butt to solder. And but I also only have a chisel tip on my soldering iron. Oh, by the way, this soldering iron is amazing. I got this soldering iron for my DeWalt batteries. And has that got a cover on it? It does. I think there's like a screen protector. Oh yeah. That's why it was looking so icky. Yeah. Like a film covering it. Much better. But all I got is this chisel tip for it. I gotta find out what tips this uses. Does this use threaded tips? It does. Okay, it uses just these kind of tips. Okay. Oh, I see. It slides right over the ceramic PTC heater. Yeah, so they're waiting for me at the post office. I'll pick them up after the stream today. But I have a 12 amp hour battery. It's probably not actually 12 amp hours. Um, it's probably less than 12 amp hours because it's a knockoff battery. But either which way, it's a huge freaking battery. 20 bucks. Hello. Hell yeah, I bought that. This battery will run my router and my cable modem for 8 hours. I've already tested that. I have a little power inverter. So in a pinch, I can plug my cable modem and router into that and get 8 hours of runtime. Already tested that off of this battery. So I decided I like this also for my soldering iron because it's big, so lots of capacity, but it's also heavy. So the soldering iron doesn't move around. I ran this soldering iron, has to be 2 hours yesterday, 800 degrees, and it's got to be at least 2 hours, maybe hour and a half, 2 hours, and the battery's only down to 72%. Hell yeah! I like that. So yeah, that for me, that's a definite buy. I like that a lot, and it heats up freaking fast too. Seconds, like less than 5 seconds at that temperature. But yeah, that's a nice little unit. I like that. Just here we go. Actually, just take a picture of that screenshot, and then use the image search on AliExpress, and it should pop right up. I paid like $23 for it. That worked really nice. I gotta get some tips for it. But the PD trigger was kind of interesting. It actually I was worried at first because I got it, the switches set, and I checked it. It was putting out 5 volts, but then I plugged it into here to see how much power it was drawing, and it was drawing almost 7 volts. Like, what the hell? Will 7 volts fry that BMS? But no, even though it was pulling 6.7 volts, the output was still a rock solid 5 volts. I'm not sure how that works. It's almost like the adapter was adjusting its voltage output to maintain as the amperage increased. I guess that thing is that complex. I mean, it does have an 8-pin chip on there, a 10-pin chip. It's got an IC on there, so I guess it's smart enough to do that. But yeah, it was pulling 23, 24 watts. Nice. That's well within the spec of this battery, and that'll recharge this battery in 3 hours. Um, I'm definitely very, very impressed with this. I want to do more with these giant batteries. But whose turn was it to bring the donuts? Love donuts. I like the filled donuts ones. I like the cinnamon powder covered ones with the apples inside, and the lemon filled ones. Oh god, I love the lemon filled donuts. And I don't like the jelly filled donuts. They're too sweet. They're actually too sweet. Um, but the Entenmann's, the garbage donuts of the world, but they do taste good. I hate the fact that I have to buy the big box with the 3 different kinds, plain chocolate or I'm sorry, plain powder and cinnamon, just to get my cinnamon donuts because I love my cinnamon donuts. But you're right, their chocolate donuts are pretty good. Um, but I also like the blueberry. I call them blueberry donuts, but they have like a jelly inside, but it's not like the you ever chop up Jello and it makes that like textured jelly like look. that kind of jelly. I don't like inside the donuts, but the donuts that have the smooth jelly inside, that's like blueberry flavored, and it's like smooth, that I love. That's my favorite. Yeah. um, this part I just print it in plastic for now, but in the final model this will be printed in TPU, and that is a cover to give you some shock protection. Although I might just print the whole thing in TPU. See how that goes. But just to make sure everything fit, I printed it just in PLA for now, and it fits great. What I might do also is I might close off these ends, but have them open underneath, so like it'll just be like an angle. This way, nothing goes in, nothing comes out, very easily, and easier to print. Although this printed fine, I didn't have any problems printing it. And of course, I'm going to have to put a hole here and a hole here, so this can be screwed in so that this doesn't fall off. I might also restrict this opening a little bit and have this entire head be part of this. Have that whole head separate, and then just have 4 screws so that you can install the emitter. And then when you put this down on top of it, including the other part of the head, it'll actually compress and hold the LED emitter and the heatsink in place. Yeah, vents on both sides. That heatsink is like 50 times overkill. Okay, we're only dissipating 4.5 watts. that heatsink will easily dissipate 20, 30, 40 watts. So that's technically this doesn't even need a heatsink. The aluminum substrate is enough. But I wanted a good quality heatsink on there just because I can. So that copper is, you can use an aluminum one. They're a lot cheaper. Okay, but I wanted to splurge a little bit on this one, so I got copper. 2 of them. Nice. These are $7 a piece, while the aluminum ones are $1 a piece. So big difference. When I make the big area utility light, that's going to use aluminum heat sinks. But for this, I wanted to use a nice copper heat sink. I need to shrink it down a bit. I like the proportions, but it's too, I have gigantic hands, okay? My hands are big, and I can't wrap my hand around this thing. So, I got a lot of extra room in here that I don't need. So what I'm probably going to do is keep this part of the flashlight big like this, because I did end up using pretty much all the area inside for the wiring. Also, the threads don't need to be this long, so there's the mess inside. I used all nice silicone wire, all JST connectors to keep things simple. The only problem is these new crap wires that I got. I didn't realize they were different. They're not marked. They're not marked as to what their gauge is, but they're definitely, you can visibly see they're a thinner wire. They can't handle the 25 watts. Well, they don't get hot, but they get warm, and I don't like that. Oh, thank you. They're actually kind of a disappointment because the picture showed a much higher quality earring. But thankfully, from 2 feet away, you can't tell. But still, I can tell. I don't care as far as the price. It cost me $1.59. I don't care. The problem is they advertise them as much nicer. So the actual, like the hoop and this backing plate that the purple jewel sits on, it shows a really nice quality metal construction, while this is literally just sheet metal stamped. It's the cheap ones. It's like these. It's a super cheap. It'll focus in a second. Yeah, it's a super cheap sheet metal stamped cutouts. They're not as comfortable on the ear because they got a little bit of an edge. They're cheap, when I pay $2 for a set of 5, Halloween earrings, I expect them to be cheap. But these, they showed a picture of much nicer construction than what they actually came as. And why lie? You're selling them for $1.59. Why lie? Just show a picture of the actual earrings instead of a rendering. They're still very pretty. I like them. The purple shines up really nicely. But I'm wondering if there's a version of them out there that actually are nicer. Let me see if I can find a picture. I'll show you what I'm talking about. Michelle's doing good. They have apparently there's an overhaul at the facility. Um, Complete new administration, new therapists, everything's been changed. And so they called me yesterday in a conference call with them and Michelle and me to go over what's going on. And so within 2 weeks they're going to do another evaluation and then get her back on therapy. More than just the restorative therapy, get her on the actual, go to the whatever and get her on her feet kind of therapy. So hopefully, let's hope it works out. I want to get her out. Let's see. Yeah, you got to be very vigilant about it because they don't have any vested interest in it, so you have to be the one to push. Where the hell are they? There they are. Actually, I paid $1.39 for these. Well, she's in a rehabilitation center because she can't walk. I mean, that's the one thing that I can't do anything about. I mean, even when I was on varsity football in high school, I couldn't pick up a 350-pound person. I just can't. I'm not strong enough to pick up a person that heavy. And she can't use a walker or a wheelchair inside the house. The openings aren't large enough. And outside she can use them, but not inside. She has to be able to get around the house with a cane. So they have to get her back into the shape where she can walk again, and then we'll be good to go. Yeah, see here? Here's the see how it looks like a nice solid clasp, shaped metal. See how this is nice shaped metal? While the actual earrings are just stamped um, metal. Like it's flat and just die cast or die cut. Nowhere near as nice as what they show in the picture. And the reality though is you really can't see that from a distance, so I don't care so much, but it still annoys me. It's like, why lie? Like, don't lie. Thank T.Y. Famalam. Is that supposed to be thank you, family? I mean, they're taking care of her. They're not doing anything bad to her, but they're also not giving her the physical therapy that she needs to get her the hell out of that place. Her roommate's dying of cancer, and the last thing I want is for her roommate to die in the room with her. I just can't imagine how that would mentally not be good for her. Just don't want her to be there when that happens. But I do need to look for a new switch. Single pull, single throw switch. I want a big beefy switch. Hey, James White. I want a big beefy switch, like a really nice proper switch, but I want it large enough to be glove compatible. want is the slider. There's a slider. Now we need something heavier duty. Come on, they gotta have some heavy duty switches. Nice. There we go, 3 amps. That's way more power than we're gonna pull. Awfully expensive though. $2. How big is it? I hate when they don't have dimensions. Oh, what's the malfunction? Why can't you provide fucking dimensions? Here we go. Switch total size. 35 by 13 by 18. Mounting hole diameter 28. So it must be 28 by 13 for the mounting hole. And then the 2 tabs on the end extended to 35. Okay. You guys see what I'm looking at? No, you can't. That seems reasonable. A nice big chunky switch. Because I want to make sure that well, there's 2 things I want. First of all, I want the switch to be massive overkill for what we're doing. We're drawing between 4 and 5 watts maximum, which means 1 amp. This is rated for 3 amps, so I'm okay with it. Actually says 6 amps. 125 volts, 6 amps. But I also want to make sure that when I install it into here, that none of the switch comes above the edge of this, so that this moving around in your drawer or your bag or whatever doesn't accidentally turn it on. And so I don't want this sticking out. I didn't realize how big this freaking switch was. But so yeah, I want to shrink that down massively. But I still want a beefy switch, and I'd prefer to have a slider switch. But the reality is, I would rather have a multi-position switch, so that I could now this has 6 connections. Is it a double throw or 2 position? This says DPDT, but this is an SPST. It says 2 positions. Um, 3 position. Why does it have 8 pins? Okay, that looks like it would be difficult to mount. It's a 3-pin 2-position. So it's not going to do what I want. I need 3-position. I don't want 2 separate switches because then it's possible for you to turn both switches on and that will overdrive the LED. We don't want that. I want a single switch with just 3 positions. Although a rotary switch would solve a lot of the problems too. And you know something, an adjustable switch would also solve a lot of the problems. All we have to do is set the max point, turn the potentiometer all the way up, and then use the constant current driver to set the max point, and then you can just turn it down to whatever brightness you want. That could work too. The only problem is using a potentiometer means you're just going to be bleeding off the excess power as heat. Not a lot, but still some heat. It'd be better to have 2 constant current drivers and 2 fixed set points. But a rotary knob would solve a lot of the problems too. Terminal 3 position. What's this? What? I'm guessing normally closed, normally open? I don't know what I'm looking at. I have no idea what I'm looking at. Why does this have so many pins? It should only have 6 pins. Or 3 pins if you're just controlling one leg. Do you guys know what I need to type in for what I'm looking for? I'm looking for a switch like this that has 3 positions, so I can make the center off, and then this one on, and then this one on, so that I can run the high power constant current driver through one side and the low power constant current driver through the other side. And actually, probably what I would do is I'd make this way off and then low, high. This way, turning it off, you don't have to find that middle position. You just push it all the way down to turn it off. But what do I have to look for to do that? I don't know what I actually need in order to do that. Oh, God. It says 2 and 3 position, but it's a toggle. Although, with that being plastic, I can shorten it. That's a 2 position, 2 position, 2 position, 3 pin, 3 position. Okay. Doesn't have the tabs I want, though. Okay, so 3 pin, 3 position. Is that just a toggle switch with a freaking thing on top? Yeah, I think that's exactly what that is. That's a 2 position. That looks nice though, but I need a 3 position of that. Let's add 3 amp. Should reduce the... Okay, now we're getting a little better. There's 10 pieces. That looks like a 3 position. And that's got the right number of connections. Well, that's the problem with the rockers, is they're too big. I'm sorry, I didn't show you guys the screen. The problem with the rockers is they're too damn big. You know, it's freaking huge. It sticks out too far. I want the switch to be recessed. So that's why I'm looking for a slider. I'm looking for something like this. Okay. That's nice and beefy. 6 amps at 125 volts, 3 amps at 250. Okay. And it's a... Oh, wait a minute. That looks like a 3 position switch. But that says 2P. But it says here 3 positioned. Even with the shipping price, that's not so bad. Add that to the cart. You get 10 of them. So for $5.78, I get 10 of them. And this one's got full dim specs. Nice. Including the center line, 28 millimeter center line. Very nice. The switch body is 22 by 12.6. That's a full layout. That's nice. This is what they should include, because that allows me to design for it. Okay. That would work. Now let's see if we can find it cheaper, because I'm greedy. So you just do this, and then you do this. Go, 5 pieces for $1.25. Do we have any choice? Yep, here's choice, $5.49. Here's choice, $3.71. Although that looks like the smaller one. 5, G7, G9, 10 pieces. So that looks pretty big. That looks like the same thing with a slightly shorter switch. 3 gear, I'm guessing that means 3 position. I don't know if that's actually 3 position or not. What does 2P3T? Two pole, 3 throw, or position. Okay, so that is what I want. I think 2 pole just means it has 2 sides. So it has 6 connections. Which doesn't really matter to me, but that's good. I can live with that. Okay. But 3 throw or position, that is what I want. And I do want the big ones. That is 12.8 by 28. That is for the G6. So what's the G10? 12.8 by 28. How could it be the same thing? Oh, unless the difference is the length of the... Oh, I bet you these are all the same. And the difference is the length of... Yeah, it's the length of that little switch. Okay, so we want the short ones. Because we don't need it. I need the switch to be big and not long. Yeah, they're all the same. 28 by 12.8. So the difference is the length of the little switch. As long as this part here is chunky, then your gloves will be able to get a hold of it. Okay. And that's $3.75 for 10 of them. Hell yeah. Yeah, what the hell? It's things I didn't want to delete, but I don't give a shit. Okay. I don't think we're going to beat that price. Those are tiny. I definitely want the wings. Okay. Yeah, but 16 amps is way too much. Remember, we're only running 1 amp. So 6 amps is 600% of what we need. Yeah, I can't argue with that. That's 35 cents a switch. And it's beefy. Okay. So we got the switch. Now what I need is to figure out AST pigtails. Triggers are fine. So I guess the trick now is, how do I find better quality version of these? Because the ones that I have, these here, the red ones. What the hell? Oh. SYP. Is that what they're called? SYP? Yeah. Ah, here we go. That's just 20 gauge. And it says silicone. Okay, that's what we want. It costs quite a bit more, but that's okay. I wish I can get longer wires. Well, I can easily search for this. Oh, it's on a Dollar Express. Nice. Oh, come on. Why is it taking so long? What I need is longer than 10 centimeters. It's only 4 inches. I'm going to add it to my pics just because it's good. No. Delete that. That already has silicon wire. I'll add that temporarily. Nope. And no, let's do a search first. Is 20 gauge enough for 5 watts? Or 25 watts? I don't actually know. These are 20 gauge, and I see longer ones. "20 centimeters the longest?" The best I can do is 10 pairs. That's annoying. $7.90. So it is cheaper to buy the 15. You got to be careful with that. Sometimes it's actually cheaper to buy multiples of the smaller set than it is to buy the larger set. Okay, what can I delete? Let's just see what happens. Oh, that worked. "200 millimeters is 20 centimeters. So let's look for 20 pairs. Right there's 20 pairs, but it's only 22 gauge. No, definitely don't want that. Oh, it's got it on both ends. That's interesting. Yeah, I like the silicon wire. I think I'd rather just stick with the silicon wire. Oh, there's silicon. And that's the same price. 34 cents. It's a penny cheaper. But I can get it in 18 gauge. 200 millimeter. 60 bucks. So it's cheaper to buy the other one. Although let's go same. 47. Still cheaper. Okay. That's 8 inches. That should be plenty. Ring terminal, 20 gauge silicone. If I can find this shit pre-made, why not? I definitely don't need XT60. But finding some light duty preset ring terminals would be nice. Probably not going to. Probably best to get something like this. Or this. heat shrink ring terminals. They're nice. Yeah, that's nice. Oh, this is all rings. Oh, it's almost the same price. So I'd rather get that. Okay. We also have these. 22 to 16. So the red is what I want. What's the difference here? Oh, okay, I see. So 6.3. What size are these bolts? Bolts are looks like it's M5. So the 6.3 millimeter would be enough. That seems like a lot of money though. Why do you gotta annoy me? Because I have too much shit in here. Just in case an address shows up. Let's delete that. That one too. I don't want to delete the fish. I want the fish. That. Delete. There's the heat sinks, 40 by 40 by 11, $9.37 for 10 of them. It's good. It's good enough for now. Let's add this to the cart. Good. Okay, so I have the stuff that I need added to the cart. Now where's the switch? It's 12.8 by, what is it again? Shit. There it is. Showing your screen? I'm not. Come on. Want the short. There it is, G7. Those are even shorter. Oh, there's no price difference. Need is this. So we are 12.8 by 22. 28 millimeter on center. So we're going to make it 13 by 22.5. Okay. Goes that. Goes that. Okay, what I need to do now is I can shrink this down by quite a lot. This is 41 millimeters. How big is the opening now? Jesus, this is running so slow. Okay, so I'm going to need this. This. Okay. Let's do this first. Okay. Let's split this apart. I no longer need this. Now let's split this apart. Split you apart again. There it is. Okay, there's our primary opening. That is 50. So if we want to go from, and what is our dimensions on this? .40 millimeters. Yeah, it's 40 millimeters. So we're going to go with 42. That'll give us clearance for the wires. Better go with 40. No, I'm going to put a slot in it. I'm going to put a slot in it for the wires. So we're not going to give it any clearance for the wires. So we're going to go 41 millimeters. Okay. So let's do a whole bunch of different changes. First, this does not need to be this big. This can be, I think 3 threads is enough. So if we want the inside diameter, go from 50 to 41. Do some math. So that's going to be 2. 41 divided by 2. Nope, that doesn't work. The only reason I don't want that kind of a switch is because it's too easy to accidentally trigger and they're not very heavy duty. How did I do this? 50 divided by 100 is 0.5. So we want to go to 41. 1 divided by 0.5. 82%. So we need to shrink this by 82%. Now, how do I want to do that? I think what I need to do is take this and this, Control D, you're going to go this way, you're going to go this way. Oops, I got to bring this over here. That looks good to me. Now, what I think I need to do is take this not join it yet. But if I take all this and hide it to allow me to delete all this. Okay, bring it back. So this is going to be the front half. Now we take all of this and we shrink it to 82%. Okay. Now we take this join it. Now, that body has the appropriate size hole for the battery. So does the tail cap. Okay. Come here. This. Align here. We're going to center and center. You move this way a little bit. Uh-oh. Okay, I missed something. Let's hide you for now. Oh, I totally munged that. Okay. I need to hide this and this. This needs to be taken out of this. And this needs to be taken out of this. And now these can be joined. There we go. I have my merger and my threading. Okay. Yeah, that looks good. Okay. Now we bring this, bring the parts back. I think I want this to be part of this. Yes, that's what I want. Okay. Now we hide this. I am showing you guys my screen, right? I think somebody would have said something by now. On. Yes. Okay. Now, do is we put the floor down here. Drop this to the floor. Okay. Go away. Well, why are you in my face? Why is this here? Oh. Now, let's double check the length. Length is 165. 163, close enough. Okay. Should be able to join these. Okay. Okay, that's about there. Let's do this, this, and this. We're going to do an align, anchor you, here and here. Okay. Now we take this, bring it all the way down to, I think there. I think that is sufficient volume for the goodies. This is wrong. Why is that like that? Okay. What we need is to do this. Okay, we take this and this. Fine. There we go. Now we take these three. Join. Okay. That's more like it. Now what I need to do is a shimmy shimmy between this size and this size. So the only thick part needs to be where the volume is going to go. Means I should be able to just lop off most of this. Okay. Let's do this first. Then do this and this. join. And we take these two, join that. Oh, I didn't get it all. I love how you just magically miss so much of it like that. It's like, how? It sure looked like it was covering it to me. Okay. Is there any particular reason why you disobeyed me? There's going to be a slot running alongside the battery. We'll see that in a second. Okay. I'm liking it so far. I think that's enough room for all the electronics. Okay. And now we put a cone on here. Okay, let's close this. Keep it transparent. We already know that's 50. And we already know this is 41. Okay. So all right, base radius is 25. Top radius is 20.5. That's going to be a hole. Control D. Not a hole. 61.1. Let's just make it 30.5. Be 0.5. A base radius of it's going to be 36.5. Okay. These are aligned. Merge them. Okay. Should be able to take this. This is 20. So that means we're going to take another 20 off of this. That'll increase our interior volume and reduce how much we have to print. You're already 20. Now I can take this, chop it. Okay. Now we take these two, align on center, here and here. Not what I wanted, but that's okay. I know how to fix that. You there, and drop. There. Now we have a smaller, easier to manage handle. We're going to put a piece of foam in the bottom so it doesn't jam that end of the battery. That would be very bad. And in fact, I might even add a support in there. We're good. We're going to put a slot in there. You're going to see that in just a moment. But I had to finish constructing this before I could do that. Now, one thing I guess it's okay to have it that long. Especially if I end up printing this out of TPU, more threads better. Okay. So now we need what the hell? Really, cat? You just gotta knock all my shit over? I'm gonna kick you in the head, cat. Yeah, see how you like it. Knock you off the desk a few times. Probably not very good for that battery to be dropped. Punk. Okay. So first, I still need this. Hold D. These two are going to have to join. This one's going to have to join. That is not a joint. Okay. To 0.5. There, now they're overlapping. There we go. That's what it's supposed to look like. Now we take this and we align here, center. Come on, I clicked away. Get rid of the transparency. It's going to be about like that. Oh, that's right. We have to, this is curved to fit. Transparent. Got to have some meat here. Kind of screwed that up though. That's all right. It's close enough. Okay. Now we take that apart because we don't need this. Now we take this here. This is going to be 13 wide. What was the length? screws right there. That's the wrong picture. Is this one? Yeah. And we are 22, so we're going to make it 23. I think this needs to be wider. Let's make this 13.5. And let's make this 23 long. Okay. Now we take these two, align on you, center and center. I'll make you taller. Shove you right down its butt. It needs to go all the way inside. There it is. It's inside. Okay. Now we take this, that, that looks good to me. All right, now these two join. Okay, we now have our insert for the switch. Now we take two of, oop, I can't do that yet. It's not going to go straight. So let's unjoin this for a second. I need a flat surface. Why won't you work? Now, how big are the holes? All right. M3. Okay. So we need this to be 3 millimeters. 3 by 3. Why can't I move this? What is it doing? Jeez. Now I can join this. Okay. Control D. We're going to go 28 millimeters. Join those together. Unjoin again. Now we take these two, align on you here, and now we join them all together. There. Now we can screw the switch in place. Okay. Now we handle putting in the slot for the battery. Let's do a 4mm, 4x4. That is so not what I fucking wanted you to do. Okay. Okay. Take the two of you. Line. Here. Center. Okay. We're going to do this. This. Remove you. Too much. Actually, that might be about right. Okay. Hold D. Ooh, I just realized a pretty big problem. That is so not what I asked you to do. You just completely ignored. Oh, it's because I had the work plane. That's why. That's what I need you to do. See? Now I have a little. See, now there's a little shaft in there for the wire to pass through. Right there. But I just realized I cannot do that for the bottom. Because the bottom is going to rotate at least 5 times. Shit. Damn. I don't know how to fix that. Yes, I do. I have to put threads on this part. Well, I fixed it for this part, but there's not a, normally what you would do is you just make the inside diameter here large enough for the wire to move all the way around. Problem is my tolerances are too tight. See? That inside diameter would eat away at the threads. So that's not going to work. What I can do, however, is make the threads part of this piece, then have the cap screw onto the outside of that piece. That would solve the problem. Now, how best to do that? I think we're getting complex enough that I need to go to a new work plane. Copy. Delete. New design. I thought I had enough meat in the threads to allow me to just cone it out. There isn't. There might be a way I can make it work, but I don't feel like fighting with it. Plus, I wanted to invert the cap anyway, since inverting the cap will allow me to print the body out of non-TPU material, and then I'll just have to print the cap and the other part out of TPU to give me the shock absorption that I want. Okay. Okay. I have no idea what I just did. I know what I did. I think. I can get rid of this and just extend this. Like that. There we go. This. And get this. This. And one more. There we go. This. That. Join this and this. Well, why would you disobey me? Those two plus this. Now I could take this all, join it. No, that's not what I asked you to do. Yes, it is, because I forgot about that. These two join. These separate? Yes, they are. I want these to be one piece. Join you first. Then join you to that. Okay, that takes care of that. I also might have to extend this a little bit. I'll have to put a square in here and see if there's actually enough space for the beef stick. Hey, Cassandra. Okay. Okay. I want to do this? I deleted something I needed to keep. Yep, I deleted something I needed to keep. There it is. I need you. We need to rotate you. Not yet. Just gotta rotate it with that. That for now. I might need that. No, I don't think I do. Yeah, I do need it. Drop. Now we take this, bring it down here. Now these two can be joined. Seriously? That and this. Okay. Does that have to be redone? Yes, it does. Come on. These separate? Yes, they are. So first, need those to be joined. And this to be joined. And that might be a problem. I think there's a gap here. Yeah, I see triangles. There's a gap. I think I caught that. All right. 20.6. See if that gets rid of the gap. Yes. Looks like you got rid of the gap. Okay. So this needs to be duplicated. How are you doing, Cassandra? Okay. This. No, I need to split it first. This. Yes. take this. I didn't get the piece. Why didn't it select both? Come on! Why isn't it selecting the rest of it? Is it already separate? It is already separate. Oh, that makes my life easier. Control D. Do this and this. Okay. Nice. Happy victims. You know what you tell everybody? Be happy or else. Okay. All right. Now, how do I want to do this? All right. We're going to take this, this, and this. And we're going to do a 180. Because these pieces are going to have to cut into this. And this is going to have to go into here somehow. So let's see how I want to do this. $28.35. $28.35. No, wait a minute. No, I don't have to do that. All I have to do is merge these. Oh, I never sent Michelle the link. Not a big fan of the way this cuts a hole in that, but I think we can live with it. I don't think it's going to compromise its integrity. It'll be a little trickier to print, but it should work. And if we're going to have the top fully removable, we could print it from this end. No, that creates a problem too. I could cone it. Yeah, I could cone it. Yeah, let's do that. All right, base radius is going to be 25. Top radius is going to be 20. Not enough angle. That's enough angle. You and you. Line. You. Help. Help I what? There. There. That is incorrect. How did that get incorrect? This should be 50. Oh, it's 61. So that means 32. Okay. Not a fan of the angle. I think I need a little more. Let's go a 17. Yeah, I think I can live with 17. Hey, Michelle. Okay. That's going to be a hole. And we're going to control D. Not a hole. We're going to make this one 33. And 33. Okay. Hide you. So I can select both of you. We're going to join. Turn you into a hole. Bring back the piece. Line. Here. Now we join. Okay, why is that so small? I screwed up somehow. And why is that so short? I aligned it with the end. What did I do wrong? Oh, it's just because the dimensions are wrong. Did I just undo the center of that? Hide you. To undo. This needs to be 25. That's more like it. That's more like it. Okay. Yeah, this needs to be an off-center thing, but oh well, it's gonna have to do. Yeah, we got enough meat there. Okay, what I need to do is put a little bevel on there. They're doing good. Actually, they're both right here. There's Ender. There's Ender. And can't quite see him, but over here is Nolsey. There he is. There's Nolsey. Hi, baby. They're being good boys. They like my nice warm blanket. Okay. Think about it, think about it, think about it. How do you want to do this? I got to clean up that because that's not going to print. That's going to fail right there. Not fail, but it's not going to be nice. What I need to do is to put a cylinder on the end of this and have that cylinder overlap this here. I believe that's going to be 33 millimeters. Probably make this 5. This 33 by 33. Line, center, and here. Not even close. What the hell? How big is that? Oh, 66. 33 was the half point. No, that's the outside 66. The inside was 25, so this is going to be 50. Line, center, and center. Okay. So we're going to want these to overlap. This is going to have to come apart. We're going to have to come apart. This. Join. Take these two, join them. Bring this back. That does it. Not really. That just creates a new boundary. I need these to actually intersect. Okay, so we need a cone. And these need to have holes in them. This needs to be a cone. This is going to go all the way through. Okay. Now I know what I need. You to be right there. And the base radius needs to be 50, which is 25. Top radius is going to be just a little bit smaller than that, so let's do 22. The height is going to be, call it 6. And we're going to need more sides. Okay. Now we take these two pieces, align them on this one, here, and here. That gets us our merger. That's what we want right there. Now we take these and join them. Okay, so now we have printability. Except that looks wrong. .1. Need a tiny overlap. That should. Yeah, it's a little glitchy, but we'll correct that afterwards. Oh, actually, we could check. Just by going transparent. Yeah, I think we're good. We take this and this. Why are you ignoring me? This and this. Why are you ignoring me again? This and this. Okay. That should do it. That's for that part at least. Oh, come on. There's our channel for the wire. Change the color to something tolerable. Okay. Now we got to hack this end. I no longer need this. Okay. Okay. My nose pierced? Never. I have no reason to want my nose pierced. Means I don't need this anymore. Okay. Let's see, how do I want to do this? First, let's do this. Then let's do this. Okay. Let's do this. Nah. I'm not into piercings. I like earrings because they're decorative. But, you know, that's where it stops. I mean, I have no desire to get a piercing. Okay. Why is this dark? Because there's a cylinder cut out. Okay. Which means I don't need that. I might need this. Okay. How much depth do I have here? Come on. Approximately 32. How big is this? 31. That's okay. All right, we can do that. Drop. Now, I think I'm going to want that to be a little bit deeper. Come on, invert. Why the hell won't you invert? It refuses to invert. What the hell? This should pop over to here. That's annoying as F. I want this to be a little bit bigger. That means I no longer need this. I want to put this down here. This. Drop it in a little deeper. Okay. And now we join this together. That is not what I asked you to do. No good scumbag. I'm going to do more than hurt its feeling. I'm going to kick its ass. Freaking disobey me. Be ass whooping time. This and this. What's the problem? This and this. Why the hell can't I join them? What the fuck is the problem? there it goes. Why wouldn't I do that the first time? They are touching. It just, for some reason, it wouldn't let me do it. It kept unselecting it. That was weird. Okay. Freaking weirdo. Okay. Now let's see. Wait a minute. I got to. Need this to go in here. This to drop. Come on. Yep, we're good. Plenty of space. Okay. Now, I do need to make one more change here, because otherwise, these are going to chew up the, they're going to chew up the, wire a little bit. Why? Why are you selecting the rest of this? I just want you to select those two, but you want to select the rest of the goddamn board. That is one thing I wish they could fix in Tinkercad. It drives me crazy that it keeps selecting crap that's not even in its range. Oh, makes me want to rage. Like, why? Why do you gotta do that? Why do you gotta be a dick? Come on. Which one is it? Go away. It's this one. There we go. Just got to nip away a little bit of the threads so it doesn't tear up the wires when I rotate it in. There we go. This way, the little bit of wire that peeks through these little holes right here won't get ripped up by the plastic threads. Okay. Now, there's something else I could do. I could build the BMS and the PD trigger into the bottom of this. But no, then I have to run the battery wires down here and the power. No. We don't want to do that. We don't want to do that. Nope. That would be bad. Doing it this way, we only have one wire going up and down. Okay. Oh yeah, we did want to check one more thing. Would you please settle down? This computer is really struggling. It shouldn't be struggling this much, though. It's that hard drive. It's a bad hard drive. It's got to be what's doing it. I'm not suffocating it, am I? Ooh, I might be. Nope, the vents are clear, so it can breathe. I'll give it hurt its feelings. Okay. It is. I need 36 millimeters for the entire thing. Do I have 36 millimeters? So 13 by 36. Sometimes, but you see the problem is the problem with the printables contest is you can't enter an existing model. And so the idea is for you to design something in the moment. And I'm not very good at that. Okay, we do need to make this a little bit bigger. What the hell is it doing? It was going crazy. Does anybody else see that that's a separate thing? Oh, it wasn't finished processing. Of course it wasn't. I could probably make that channel just a little bit smaller. Minus 0.5. There we go. Tis good enough. I can merge that with this since I don't need to mess with this anymore. Yeah. That can merge with that. It's out of my step process. Okay, now this next unmerge should give me my cut. There it is. Okay. These need to be locked together. Okay. This needs to be bigger. Let's make it 62. Yeah, Logan. In the building? Okay. All right. Bye. So to enter a printables contest, I'm sorry, I forgot to finish answering your question. I would have to design a model specifically for that contest. Sometimes I happen to be working on something that I haven't uploaded to printables yet, and it works out, and I like the rocket one. But otherwise, if I don't have a desire or demand to design something for that contest right now, then it doesn't really work out. Okay, so let's go 63, 64. First things first, let's get these merged. Then let's get these merged. I can live with that. And now I should have the 36 millimeters that I need here. Let's double check. I hate when it uses these colors that just look funky. No, I do want that to be a different color. You can tell that they're not merged yet. By 36. Yep, just barely. That fits. Okay. All right. Now we can join this together. Okay. I think we got it. This will look something like that. All right. Then all the gear will go here. I'll have a lot more room this time because the switch is not going to be nearly so obnoxiously large. Now, I also need a spot to charge, which I would also like in the recessed location. Okay, let's go back. Go. Um, where do I want to put it? I'd like to have it in here. Control D. I guess the real question is that enough space? Let's try this. I need to put a square here, because otherwise I won't be able to flatten it because there's no flat surface. Yeah, that's plenty of space. This still does not look correct. It looks like these are not overlapping properly. Is it just an overlap or is there a gap? I guess we'll have to see when I print it. If it's just a slight imperfection, I don't care. But that should not be there now that I've cut this out of there. The only way that would be there is if there was a gap. I better do something about that. Let's go 151. There, I just saw it go away. I saw the shadow disappear. There was a gap. Still have the line though. I don't care. We'll see what happens when I print it. Right. Bring you back. Control D. Come on. Why aren't you working? Well, what the hell were you moving? I saw the numbers moving. Hey, Jerry. Yeah, be careful. Do not look at that screen, buddy. It's frozen. I don't know what it's doing. It may have crashed. Hey. Ooh, something I want to check. I'm trying to keep this piece under 250 millimeters. Two hundred and 40. Good. Okay. Good, good, good. Go. Okay, so that is the space that is going to be consumed by the switch, so I have plenty of space for this. Okay. Now, how big is this? Okay. This is we're going to call it 6 millimeters by 11.5 millimeters. We're going to call this 6.25 by 11.5. Just double check that. Yes. Yes. That should be enough for almost a friction fit. Now what I need to do, come on. Okay. Now what I do is once this is set up correctly, I will just take this and shove it from the inside after I have a pigtail connected to it. I'll shove it up into that hole. It'll stick out the top. And then I'll just put hot glue on the inside of this so that'll hold that in place. And then USB-C port will stick out on top there. Okay. So there's the spot for the switch. There's a spot for the USB-C charging port. The only problem is, unless you print this, I might actually print this in transparent PETG, you won't be able to see the light up that it's charging. Did this lock up again on me? No, it's just being really slow. Jesus. Let's make that transparent. Go eat, baby. Come on. There it goes. Okay. Oh, man, what's it doing? Yeah, I know, because my computer is suffering for some reason. I've dropped 222 frames. It says encoding overloaded. Basically, this computer can't handle what I'm asking it to do. I don't give a shit about the law. I give a shit about you dying. Fuck the law. I just don't want you to be dead. Or worse, to live with killing someone else. What is going on? I mean, it's really having a hard time. Yes, Logan. Hi. Um, I'm on my live streams. What's up? I'll call you when I'm done. All right. Bye. it's really having a hard time for some reason. It doesn't usually struggle this much. I think I might need to restart this computer. Because usually I'm not already booted up, but this time I was already booted up from doing other stuff. Really? You're just going to unselect what I selected and then say nothing was selected? Because you're a douchebag? Okay. That's going to need a healthy brim to hold that on there. Okay. I got the 2 parts downloaded. Let me go back to this. Hi, baby. And it's more than bright enough, by the way. Even with just the single emitter. I mean, that's plenty bright. It lights up the whole room. It's nice. Yeah, I'm going to make this a separate piece. Oh, here's something interesting I found. Decided to grab a can to try it. Jack Link's chili. I was like, I'll give that a shot. At least it's not stupid expensive like the Wendy's chili. I love the Wendy's chili though, but my God, $4.42 for a 15-ounce can of chili? No, 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 no. That's too much money. All right, I think you finished loading. Nope, it's still doing something. It's struggling. Okay. So I am satisfied enough with the new design and dissatisfied enough with the old design that I'm just going to delete these parts. I do not want them. So now the trick is get this the way I want it. What the hell? Even my, there it goes. Skyline chili? Never heard of it. You know who makes, now keep in mind, this is many, many years ago, but, so I don't know if they still make it as any good, but, oh, well, that's useless. It's a restaurant. I can't buy it. um, who makes some surprisingly good chili. First of all, my favorite chili is Wendy's chili. Something to do with those old hamburgers that they break up and put in the chili. It tastes so freaking good. I love Wendy's chili. But another really good chili is Hooters. They make good chili. Okay. So I am okay with the way it joins. It's nice and flush. We're going to leave the joint alone. The thing is, though, this is way too big. I can make this a lot smaller. That means I'm going to need to measure the other one. Come on. Okay. I'm going to go down to 0.1. .25 millimeters. Oh, do they? Does Walmart have it? Well, I love chili. Um, Oof. That's more, yeah, that's more expensive than the Wendy's chili. What the hell, man? That's right here, Skyline Chili. $5.74 for a 15-ounce can. What the fuck? That's a lot of money. What? Oh, I am here already. Just wasn't loading. Hey, they gave me the wrong one. I thought that tasted different. They gave me mixed berry. It was supposed to be the white tea with raspberry. That's annoying. Someone's getting bitten. Mm-hmm. Mess with me, I'm all about the biting. Okay. Okay. I'll have to work on that. Okay. There we go. Let's bring you back. Wrong way. Why? I moved right. Why did you go that way? Douchebag. Come on. Okay. So here's my threads. They are 66. I no longer need 66. I only need 25. So what I can do, okay, there, drop. We take this, move it, minus 26, minus 26. Oh, that's all right, Logan. I don't mind. No big deal. You'll be bitten later. Right? Make this transparent so I can see what I'm looking at. Okay. Oh, I can make this a whole lot smaller. Okay. That means I have a cylinder in there I should be able to gain access to. Yes. No. I need to take this way. Take this. We align it on this one here. Then we take this whole mess. No, wait a minute. Gotta bring this back. Transparent. Okay, this is in my way. Can't see what I'm looking at. I don't think I need this anymore. How do I want to handle this? Also, this was a hell of a lot smaller. That is not 25. That's 24. Yeah, that's 24, not 25.4. Alrighty. I think I need to do this. Pretty sure I can just flatten this. What did I just do? What the hell was that? Oh, yeah, one of those was for that. Mm. Okay. Oh. Okay, now it's a solid. Okay. All right. So this needs to be end thickened. At least that much. Let's do this. Let's do 39 by 39. Line. Come on. Actually, let's make this a little bigger. Just for shiggles. I like the idea of that being centered in there like that. Yeah, I like that a lot. Okay. Just because I can. No, the whole point of doing this is to sandwich it. The sandwich is the whole point. Um, so I can't do that. No, I can't do that. So this is going to go on this piece. In fact, let's make it a little smaller. No, wait a minute. How big is that? Let's see. Oh, that's only 35 by 35. So we need a 30 by 30 hole. That'll cover everything. 30 by 30. Why did it switch? Is it not? It's not recognizing I'm pressing the shift key. Doing it too quickly because the computer's running slow. Okay. Come on. Go. Center on this one. That's it. You move that piece. Okay. Okay. Hold D. That is so not what I wanted to do. But I'll take it. Okay. Now, this opening needs to be 42 by 42. Okay. Line. U. Center. And center. Okay. Now we hide this for now. Excuse me. I hit the wrong key. That depends. If you're, well, okay, so this is a, this is a 3.2 volt, 20 amp hour, 64 watt hour battery. Now your typical tool battery, let's say you're using a larger tool battery, a 6 amp hour battery. So this is 108 watt hours. So this battery will probably last longer than this battery if you run the lights at the same power draw. But your typical flashlight for a power tool is not going to run at 5 watts or 1 watt. It's probably going to run at 10 or 15 watts, which means it won't last as long. But that's not because the battery isn't bigger, it's because we're running the flashlight at a lower power output. So the plan is, I have these little things here called constant current drivers. So this is an LED constant current driver. So the voltage input is fixed by the fact that that battery is compatible with that LED, and this restricts the current so you don't overdrive the LED. This will go up to 9 watts. So we're going to run it at probably 1 watt for, probably half a watt for Firefly mode, and the full 4.5 watts for bright mode. So bright mode would look like that, and it's pretty bright. It's a decently bright light. I am thinking about making an alternative head for this. It'll take different electronics as well to put like either 2 or 4 of these in the head. So convert to a square head and put 4 of these in there so you can have a much brighter light. But that's probably not necessary. This is more of a floodlight. So it doesn't produce a spot. It just lights up the entire area evenly, which is what I prefer. I don't like hot spots because when you have a hot spot, that makes it hard to see outside the hot spot, no matter how much flood you have. This creates a perfectly flooded light. Soft shadows, even like you can't tell where I'm pointing this as I move this around because the light is almost totally consistent across the ceiling. And that's what I want. I want an area light. I want a light that's just going to light up a bunch of stuff. Now, when I say forever light, I don't mean it's going to run forever. Obviously, you have to recharge it. You're eventually going to run down the battery. What I mean by forever light is that it's the last flashlight you'll ever have to buy for this function. That's why we're now shrinking everything down, because that's way too big. Way too big. So in Firefly mode, I'm hoping to get this to run for 1 week on this battery. In bright mode, you're probably looking at 12 to 18 hours. We'll have to actually test that and run it and see what happens. That's using this. You can buy you've seen those little keychain flashlights with the little square LED on it. You can actually buy the emitters. So these are the emitters that those keychain flashlights use. You could buy 20 of these emitters for less than the price of one of the flashlights. So I bought 20 emitters. You do not have to buy $7 copper heat sinks. That's silly. I did that just because I wanted to. You could buy the aluminum heat sinks. You shouldn't even need a heat sink, but forever flashlight. So I want this to be properly cooled. You can get aluminum heat sinks for about $1. Hell, you just find one. Just find an old PC at a junkyard or a e-waste center or that somebody's throwing away, and there's usually going to be approximately 40 by 40 millimeter heat sink in there somewhere. Oh god. It just needs to be roughly 40 by 40 millimeters. And that'll be more than enough. You can pad. I'm designing this so you'll be able to pad the inside of it to adjust for different size emitters. And the BMS is here's the BMS. So there's the BMS for it. That's a 12 amp BMS. We're going to be running at a maximum of 3 amps. Or 5 amps maybe, not yeah, maybe 5 amps, because for example I was able to push power into this at 25 watts, which is really freaking awesome because that means you can recharge a 64 watt hour battery in 3 hours. But on your regular 2 amp charger, you're looking at 10 watts, so about a 7-hour charge time. But the point is, we're using a 12 amp BMS and we're drawing a maximum of 5 amps. And you're typically going to draw 2 amps, which means we are massively underutilizing the MOSFETs on the BMS. And that's part of the forever flashlight philosophy. Instead of using a part that can just barely handle what you're doing, use a part that is overrated and underutilized. That part is now far, far less likely to fail. This is just a PD trigger. This you set the dip switches. It comes defaulted. Put them all down 1, 2, 3, and that sets it for 5 volts. And that's it. So now your PD goes in here, and your 2 wires come out here, and they go to the contacts on the BMS. And now any USB-C charger will give you 5 volts, because you have to the way with standard USB, all I need is a USB-C socket. But most of us are going to have PPS, AFC, QF, QD, QP, or PD power delivery chargers. And those chargers will not provide power until a connection is negotiated, because they can provide 5 volts, 9 volts, 10 volts, 12 volts, 15 volts, 19 volts, 20 volts, 28 volts, 53 volts. So they kind of like, I need to know who you are. Because if I give you 20 volts and you're only supposed to get 5 volts, there's going to be a lot of smoke. So basically, this one has a chip. But for simple 5 volt, you can just, there's an appropriate resistor you put across two of the pins that tells the PPS or QC charger, I'm a dumb USB 2.0 5-volt unit. And then it just delivers 5 volts. That's what this does. This just provides the communications to whatever USB-C charger you plug into it and tells it, I want 5 volts. And this outputs 5 volts. So we need that for compatibility with all the USB-C chargers. Then this is the driver. So this is a constant current driver. This can handle up to 9 watts. We're going to be running it at a maximum of about 4.5 watts. So 50% of its rated capacity. So again, this should last very long. And we're going to be using a different switch now. But where is it at? Here. We're using a 3-position switch. But we're using I'm going to use a very different one because this is just entirely too big. But again, we're going to be using a 6 amp rated switch, and we're going to be pushing, and that's at 125 volts. So that's 125 watts. The switch is rated for 125 watts at 110 volts. So we're going to be drawing 5 watts. Okay, so way under the switch rating. Instead of a toggle, we're going to have a slider switch, and it's going to be 3 positions. So I'm hoping I can make one end off, and then you push it once, you're on low, you push it again, you're on high. And this way, to turn it off, you just push it all the way down and you're off. And that's going to sit inside of a recess here on the light. The idea is to be completely under the recess so that you can't accidentally press the switch like I just did. And yet big enough that even if you have gloves on, no problem popping that switch. And that's also where the USB-C port's going to be. And we're going to have the final model is going to have 2 constant current drivers, so that you can run low and high independently. That's it. I'm also going to make a smaller one that takes a single 18650 cell and uses a single emitter. That one will be that one probably won't have a heatsink, or we'll just use a smaller aluminum heatsink. But we're going to make a super compact one, and just for something to put in the glove box of the car. I would like to try to run that one also on lithium iron phosphate. So there's 2 reasons we're using this battery. This battery is about 14 bucks. You can get 2 of them for 25, so it's about $14.50 a piece, 15 bucks a piece. Or yeah, no, 13, about 14, because it's $26, so that's $13.50. $13, whatever. About $14 or $15 each for these batteries. The reason is, well, first of all, when it comes to things like batteries, the smaller the battery, the more prone to errors the battery. That's why larger batteries last longer than smaller batteries. 2 reasons. 1, you're underutilizing the battery, so you're not working the battery so hard. Number 2, the larger the battery is, the easier quality control is. You get more glitches, errors, and defects the smaller you make the batteries. Also, the less dendrites it takes to short the battery internally, which is how it loses capacity over time. So there's more to a larger battery than simply it being larger. It's not gonna it's gonna last longer. Okay, put it this way. If you take the little tiny 4 watt-hour battery that comes inside the flashlight, and you take a number of those that add up to 64 watt-hours, as you burn through those batteries, this battery will still last longer. So ignoring capacity, the actual battery itself will last longer because it's larger. And then on top of that, we're using lithium iron phosphate. That's one of the reasons why I had trouble finding a BMS to run it, because it's not too often you use a single cell lithium iron phosphate. This I don't think anybody's ever used one of these cells for a single battery to power something. You typically use these as a set of batteries. So this is what you would see in your e-bike. A good quality e-bike is going to have a bunch of these inside of it. The cheaper e-bikes use 18650 cells because they're cheaper. But the good quality e-bikes, the high power e-bikes, will typically have cells like this inside. Your lithium ion battery that is in your tool battery, for example, is maybe good for 300 or 400 charge cycles if you're lucky. And your battery will be down to 70 to 80% of its rated capacity. That's what they consider worn out. How many times can you recharge the battery and still be above 80% SOC? On a lithium ion battery or a lithium polymer battery, that's about 300 or 400 charge cycles. Really good NMC tenery cells, maybe 500 charge cycles. Thousands of charge cycles. 4, 5, 6,000 charge cycles. So now you're already talking about the difference of 2 or 3 years and 10 or 15 years. On top of that, because this battery is so fucking overkill for running a single 4-watt LED. Why isn't that working anymore? There it goes. It's such overkill for running that little tiny light that even if this battery degrades to 50% of its rated capacity, you're still going to have a whole day of light. The other part of the forever flashlight philosophy is that if you put this in a drawer fully charged, it's going to slowly discharge over time. My idea is that with so much capacity, even if you put this in a drawer for 2 or 3 years, you should still be able to pull it out of the drawer and have hours and hours and hours of runtime before that battery dies. And then, of course, we're 3D printing it, so you'll be able to replace parts if you break them. And I'm also going to make the end cap here and the end cap here, if not the entire flashlight, but at least the end caps, out of TPU, so to be far more resilient to being dropped. Basically, it's overbuilt. We're overbuilding a flashlight because we can. Now I'm working on how much smaller can I make this and still fit all of this. Quite a lot. That's way too big. So now it's optimization. That's what we're doing today. We're optimizing the design. We know the electronics work. We know the parts fit. We know everything is doing what it's supposed to do. The switches are wrong. We're getting new switches. The wires are wrong. We're getting new wires. For some reason, I didn't realize that these were available with different gauge wire, and these wires can't handle the 25 watts. Well, they can, but they get really warm, and I don't feel that's safe. So I'm going to use, I'm using high quality, 20 gauge silicone wire. And again, that wire is rated for 4 times what we're doing with it, twice what we're doing with it. So that's it. The idea is to make a flashlight that is using standardized components that are oversized and overrated for the job being asked of them, and components that have a lifespan longer than you're going to be alive, theoretically. That's the idea. And because the components are so underdriven and overperforming, and the body is replaceable and serviceable, you can replace any component in this thing. The whole idea is that you'll never have to replace this flashlight. It'll be a forever flashlight. You buy it once and that's it. I'm probably gonna try to sell kits, probably $100 a pop. But if you want to, you'll be able to download the BOM and the parts, because I'm going to upload this to printables, of course, and you can make your own for less than $25. The most expensive component is the battery. I'm going to spend 14 bucks on the battery. I don't know where to buy one. The best I could find was buying two. And that was $25 and change for two of them. So you'll either spend money for two or split with somebody local with you who wants another one of these batteries, and then you have to spend 13, 14 bucks. These cost basically nothing. I mean, you're gonna buy a lot and not need it, but parts are really just stupidly cheap. It really is insane how cheap you can get these things. Boy, this thing's really struggling. Actually, instead of making this computer struggle, I'll just use the phone. Shopping, AliExpress, skip. Come on, go here. Go to my orders. So, the batteries were $24.18 plus tax. So that's $12 and change. So about 13 bucks a piece. You can buy one. I didn't realize that. The only problem is it costs a lot more. $17 if you buy one, $13 each, or $12 each if you buy two. So you really should buy two because you might use it for another project, but you can just buy one for $17. Okay. The switch is $3.71 for 10 of them. The $2 will get you all the silicone wire you need. $5 will get you all the JST connections, or if you can buy just the silicone wire and just permanently connect everything, with no plugs. I'm doing it with plugs just to make it easier, but you don't have to use plugs. You can just solder everything together with no plugs. Then you don't need to buy the JST plugs. And how do I see more? Oh, here we go. These constant current drivers, they are $2.37 for 5 of them. So you can get 5 of these for $2. And the BMS is about $1. The BMS, it's anywhere from 88 cents to $1.50. So you just find, like, this one here is $1.19. I got one on the Dollar Express site for 88 cents. So it's about $1 for the BMS. Then the last thing you need is the lights. Those are, you're buying 20 of them. It's $2.19 for 20 of them. I've seen it for as low as $1.80 for 20 of them. That means you're going to get 20 of these emitters for $2. So you're going to have a lot of extra parts for other projects to have fun with. And then, if you really do want a copper heatsink, it's $8. But you can get the aluminum heat sinks for $9 for 10 of them, or just scavenge one from something. Let's see, and the PD trigger, I got 2 of them for $1.80. Now, in theory, you could just buy one of the flashlights and just replace the battery, but then you can't use a lithium iron phosphate battery. You have to use a lithium ion battery because the charging circuit built into that little flashlight is only designed for lithium ion, not lithium polymer. So you'll lose the insane longevity of the lithium iron phosphate batteries. But you can go that route if you want. And I'm going to design one for those batteries as well, because you can get a stupidly tiny little USB-C plug that like you can almost literally put it right on the end of an 18650 battery. It's so small, it's ridiculous. And because it only puts out 700 milliamps, so it's only going to put out 0.7 amps, we don't even have to use an LED driver. We can just run the LED directly off of the BMS, because by the time you get down to the 700 milliamps that the BMS will max out at, and then you get down to the the loss in the wires and the switches and all that shit, by the time you account for all those losses, you're going to be at the appropriate power to run that LED. And so the system will self-limit, so you don't even need the constant current driver. You can literally get away with just a little tiny switch, a little tiny charging module, and the battery. So I am going to design one for that purpose. Just because I can. No other reason, just because I want to. And that's it. That's all the parts. So, and then of course the rest you 3D print. So you're just gonna, it's going to be 1, 2, 3, 4 parts. So this head screws onto the body, the tail cap screws onto the body, and our new head cap is going to be 2 pieces. But instead of being this piece and this piece, I'm going to cut the head off right here and make this whole entire piece TPU, and then this Petchy. Then you'll just have 4 screws, 1, 2, 3, 4, stability to hold that on there. And now the top and the bottom will be TPU, so it should be much more survivable in an impact, especially if we make it smaller. Yeah, that's it. It's turning out much, much cooler than I thought it would. But basically, this is going to be your glove box, your toolbox, your kitchen drawer flashlight. That, the power goes out and you need to go flip a breaker or whatever, or look around somewhere in a garage or the basement. It's just going to be a flashlight that you're going to forget about it until you need it, and then we're going to design it so that it works when you need it. Okay. Let's see. Buzz off. All right. How do I want to do this? Okay, I don't need this. We're going to reshape this. Okay, let's bring the parts back. Let's hide you again. Come on. Okay, I know what I need to do. I need to take this. I need to duplicate it. Just stretch it out this way. This needs to be 25 by 25. That does not look like 25, does it? It is. Wow. Okay. And we take this and this. Line. We align it center on center. Okay. Make sure they overlap. Join it with this one. Then we join it with this. Which didn't work. Hold down the shift a little longer. Okay, we now have the hole to accept whatever size heatsink we want. Doesn't look right. Okay, it's right. There's our 25 by 25. Now what we do is we take this, drag it out. That is so not what I wanted to do. Can't you please just cooperate? So if I put this here, put this here and hit drop, what does that get me? That looks pretty good to me. But I think I could bring it out a little bit. Moving everything. Come on. Just pick that. Okay. One. You gotta be a pest. There you go. Come on. Select both pieces, please. Okay, there we go. Okay. It's looking good. Let's change colors to something a little more sane. Okay. That looks pretty good. Now, how big is this? 35. This is wrong. Where's my second hole? It didn't do it. Why didn't it do it? Oh, for Christ's sake, come on. Why is this thing struggling so damn hard? So why didn't this work? It's not penetrating? Oh, I never moved it in. I'm an idiot. Oh, Jesus. Oh, I'm stupid. That's more like it. There we go. Okay, that needs to be shrunk. Come on. Why won't it let me pick it? Finally. $20. So 10% will be 18. Or you just type percent, but 18. That's more like it. Why do you have to fuck with me? What the hell is all that? Go away. Pest. There we go. That's the way it's supposed to look. Okay. So now what you do is from this side, you just drop your, instead of trying to jam it in through a slot on the side here, instead you'll just drop your heatsink and light into that socket, and then you can shim it if you need to. And then when you screw this into this, it'll sandwich it and squish it together and keep it from moving. Okay. Now we need to bring stuff back. Hide this. Okay. How big is this? We're going to make this smaller too, because this does not need to be that big. We're going to make this no, it's okay if this is large. It's not going to hurt nothing. Okay. It's looking good. Okay. We're going to print this face down, so it should print cleanly. Oh no, we did want to change one thing. How tall is this? Oh, come on. 91.5. So if I want a 5mm wall, we got to make this 81.5. Let's make this 85. No, I can't do that either. Otherwise there won't be an opening. See? That. Okay. This just won't stop calling. They're curled up together on the bed. Come on, do your thing. There we go. Okay. So that is no support required. That will print clean. Okay. Okay. This is going to have to stretch into here. Okay. We're going to put you there. Stretch you down to here. Up to here. That way. This way. Or this way. Yeah. Okay. Back this one. Hold on. Let's hide this again. This and this. This. Join them. this back. That. Now we figure out how short we want to make this. Let's go 1 millimeter. I can make this cap really short. All I need is for this to be thick enough. This section here just needs to be thick enough to accept a couple of screws and to allow the pinching of the part, which means that should be enough. Yeah, that should be plenty. And I should be able to, oh, wait a minute. Oh, this one. This one. And this one. Join. Good. And then in this. Good. Okay. Now we put floor here. Drop it there. Okay. That is the new head of the flashlight. Okay. Now we put floor. Nope. Yeah. Now we put a floor here. Put this 3x3. 3 by 3. Probably should be 3.5. Wait a minute. I have existing screws. Let's do 3.5 by 3. Oh, I felt that. Damn. Okay. 1, 2, 4. That's enough to allow full walls. 5. Let's go out here. It's in 1, 2, 3, 4, 5. Let's go 6. That looks good. Control D. Okay, control this one. Join. Come on. Line. Right there. Stop moving. Okay. You. Come on. B. Um. Okay, that gets me that. Eat that. Now I can unjoin these. Okay. Come on. Stop moving. Come on, come on, come on. Really? That's how you're going to play it? ow, 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 ow. E. What I'm making now is the screw holes to screw the TPU cap into the lid of the flashlight. What did I just do? Whatever I just did, it wasn't what I wanted to do. I want you to go away. Thank you. Okay. Now how big are these? These I made 6, right? Oh, wait a minute. All I have to do is shorten these. Hmm. $125. 5%. $5. Okay. Now we take this, which is currently 3.5, and if we increase that by 25%, it's going to be almost 1. That's going to be like 4.5. So we need like 140%. 140%. That gives us 5 millimeters. That's good. The head should fit inside that. Fit through that, I mean. 140%. %. %. Take these 4, we move them up. Okay, something did not work right. Where's the other 2? I duplicated these already. Where's the set that I duplicated? Let's union them. Copy them. No, just duplicate. Can't do that. Because I have to use the back step here. Now I have to paste. You. That should do it. Okay, let's hide this. Let's take all of you. No. I want you. Join. Hide. Take you. Join. Hide. That's everything. Here's everything. So we hide this. Take these and this. Failed again. Join them. No, that's incorrect. So this one. Come on. I need to go this way. There it goes. What? Doesn't seem right. Doesn't that seem right? Oh, it is right. There's just not that much of a difference. Okay. So I should be able to just take this. Join it with this. It's a hole there. This goes to this. This. Let's hide that for now. Where does this go? These go all the way in. Good. Okay, so we should be able to take these, join them. Oh. Shift, select, These back. Select, join. Delete. Oh no, these are two separate pieces. There. Why didn't they penetrate? Oh, I guess I didn't tell them to. Oh, because they're all the way in there. Okay, that's long enough. Okay. Come on. Just acknowledge that I'm pressing the fucking shift key. Or do I have to press it so hard that I break the keyboard? Okay. We have countersunk. Well, the only reason I countersunk is so it'll print without support. Okay. And now we need to do one more change. We need to open up a little opening here. Really? You're just gonna keep on going? You fucking wanker. Okay. This is gonna go here. We're gonna go that wide. Rotate this way. Okay. Oh. Parent. That's all I fucking wanted. Menu. And guarantees that we cut the corner. Turn that into a hole, duplicate it. Oh, come on. It's the last thing we got to do. Yes. Okay. Take you. And you. Take you 180. Okay. Eat you. Hide you. Hide you. Now we can take you and join you. And bring everything back. There it is. Now we have our ducts that go in without compromising the strength of the rubber ring. And the screw holes are going to pop right through there. I didn't realize that. Do I care? I don't. Oh, I do care about that, though. That's a problem. Oh, shit. I can't have them line up there. Oh, that's bad. Yeah, I can't have them line up like that. Okay, what do I do about that? Okay, there's my ring. These all have to line up, but I can theoretically move the screw holes. And the screw holes are the last thing that I did. Okay. What happens if I rotate that 90 degrees? Will the line permit me to do that? That is so not what I wanted. Why did you select everything? Again. Just want these. Why did you just ignore what I said again? You keep ignoring me. Select both fucking parts. Thank you. Ooh, they're not popping out. I might be okay with that. Yeah. It's a little close to the wall there, but I'm okay with that. Okay. Take this. Join it with this. Join it. Now we take this. Unjoin. Unjoin. Join. Okay. Are they already connected? I don't remember connecting them. It didn't do it. Come on. Jeez. There it goes. Okay. Those need to move in a little bit more. The idea is to make sure the screws aren't visible. So I don't want the screw heads to scratch anything. Okay. Now I should be able to take this, that, rotate that 90 degrees. Then do this. And join. Goodbye. Dumbass ring. Make sure this all lines up. Yeah, those holes look good. That should be enough of a countersink to get rid of the head bolts of the heads of the bolts. And there is the actual threaded portion. So if I have to modify the threads, I only have to modify this one piece. Okay, I like that. Okay. All right. Now we shape the head. Really? Did you have to? Okay. Not quite what I want. Okay, so let's do this. Really? To you. You. Come on. Okay. Top radius. 32. No, I gotta go smaller. 5. Join. Hole. Okay. Should be able to just shrink this. Yeah. Okay. Much better. I'm liking this. Okay, but that did expose a problem. I have to shorten these screw holes a little bit. Let's go back. Back. Not what I wanted. Why would you do that? I didn't touch you. Get the fuck out of my face. Piece of shit. Even though it was invisible, it still selected it. Oh, that's right. Let's hide this. Split this. Split this. Okay, try that. It's selecting the wrong piece. It's like it's not there, but it still sees it as there. Oh no, I just can't see it. Oh, isn't that interesting? Okay. There we go. Screw holes not exposed. Let's make sure we have enough meat. Yeah, we got enough meat. Okay, that should be it. I'm kind of excited now. Export this. Export this. Oh, hell yeah, we're done. Right? Let's grab all this. Let's copy it. Let's put it together as one unit and see what it looks like. Let's go back to Funky Alice Robo. Oh, man. This will be a lot more refined. All right. Let's join this as a bundle. Bundle. Okay. Okay. You and you. Align. You. Here. And here. There. And now if you put this all together, look like this. Really? Come on. Okay. Okay. So the whole unit will look like that. That's actually kind of cool. I like that. Yeah, I like that a lot. Make this transparent. You see the inside. That's the battery. Yes, I like this. I like this a lot. All right. Go full screen. Here. Okay. Let's move it into the arena. This one I can make solid. Oh, nice. Take a screenshot. And none of this requires support. That's awesome. Oh, yes, absolutely. This is the same width as this. So you can see my thumb fits in there. All right. So there's plenty of space in here for my thumb. All right. And so even you with a gloved thumb is going to fit there because I have gigantic fingers. All right. So I didn't change the width of this. All I did was make it a little longer so we have room for the USB-C port. And we're changing, instead of making this deeper, because I can't really make it any deeper, there's not enough room inside, we're going to a regular slider switch that won't stick out. So it'll be a slider switch that'll be inside this cavity. And so even your gloved thumb will be able to go in there and flip that switch without a problem. That's the whole point. You know, if you, I don't want you to have to take off your goddamn gloves to reach into a little tiny slot to flip the switch. So the idea is, even with gloved hands, like, you know, ski gloves, you'll still be able to stick your finger in there and flip that switch. And yet it'll be recessed so it won't get bumped when it's sitting in a drawer like that. And of course, now we're making it a whole lot shorter. This is 335 millimeters long. Now it's going to be Boy, is this thing struggling. Now the grand total length is going to be approximately, one of these days it's going to highlight everything, 281. Nice. So we knocked over 50 millimeters off the length. Very cool. We could probably reduce this quite a bit more even. Like for example, I wouldn't be surprised if I could have this attached directly to this. And just get rid of the screw threads altogether. But I like the screw threads. But you know, that would work a lot. I might do that eventually, depending on how. This also gives you more room to be sloppy with your soldering and crap. But I could move this piece down to here, this connection joint right here, and have this divot come out of here. And that would allow me to take another, 30 millimeters off the length. We'll have to see how the electronics work out. If the electronic, because right now I'm actually using that big chunk of space in here for all the wires and crap. But if I end up not needing it, you know something? I just realized something else. I don't need this threaded cap on the backside at all. I could slide the battery in from the front. I can make this one piece. How long would this be? 246. That means it would still fit on a bamboo. Oh boy. I think I'm gonna leave it like it is for now, since I'm kind of getting burnt, and it's not gonna take that much plastic to print these parts. Because but it would reduce this down to 3 parts. I wouldn't need any threading at all. Get rid of the threads here, and have this piece here become part of this piece, replacing this section altogether. So this cutout here would instead be in this piece here. Basically, I'd bring this piece down to here. Just like that. I would bring that piece down to there. This cutout would come out of this, and these threads would go away altogether. And then this part here would simply screw into this part. Because there is no reason to open this. It's not a dry cell battery. We don't have to open this. So it's okay if once every 10 years, 20 years, you got to take 4 screws out to service this if you have to service it. As long as it can be serviced, I'm okay with that. Now, my question is, this is the only thing stopping me, because that would allow me to make this whole thing even shorter. And then it would only be 2 printed pieces. You'd have the body and the top. Now, the only problem with that is, one of the major reasons why I want this cap on the back is because I can print it in TPU. And that's a pretty big deal. Because by printing it in TPU, it's durable. It's shock resistant. But if I just print the whole damn thing in TPU, I could do that too. Oh man, I might do that. I might make 2 versions of this. Yeah, I might make 2 versions of this. And actually, now that I think about it, this really won't take long. Boy, making two pieces would be awesome. Okay, I can't do it now. I just realized the geometry on the inside will have to change a little bit. Although it wouldn't be that hard. Because of the way the parts are designed to be printed, that creates a problem trying to merge them together. I'd have to create new geometry. That's designed to print like that. But see, now the other part would have an overhang. And it'd be a pretty nasty overhang, too. I think I would still need 3 pieces. I think I would still need a plate. Oh, it didn't get the other part. I'll have to go back and get it. Because remember, this is designed to sandwich and hold the heatsink in place. And now it would be a dead overhang. But I could probably print it on this end. And then just make the battery cap slightly conical. If I made the end cap slightly conical on the inside so it could print without supports, then I could just print it this end down. Yeah. I gotta think about this more. But I might be able to reduce this down to 2 parts. Oh, that'd be cool. That would just be cool to be able to strip this thing down to 2 parts. Wow. Now the big question is if I'm gonna print the 4-part one just because it's not gonna cost me a lot, and some people might prefer that, especially if they modify this. Well, no, what I would do is I would print this end down like this because this has to be flat in order for the heatsink and light to sit on something, and this side would then squish it in place and screws, and that's what's going to hold the heatsink and the LED in place. So this end has to be flat, which means on the inside, that's a dead overhang. Now, I might have to make it multi-part. So I might have to have a third piece, which will be just like a 5mm thick plate right here. Because the other problem is, if I do this, you're only going to have a 30mm hole to reach in here and work with things. It'd be just barely enough to fit this battery, and I would have to hope that this battery will slide past all the components in here and fit in there. It might still be worth doing that, but I'm not going to be able to confirm that until I print the existing one that I just finished, and I get the new parts. I'm gonna have to order the new parts. So it would still be 3 pieces, but the third piece would be nominal. It'd be a plate. It'd be a round plate with a hole in it, and that would permit you to have open access to be able to get in here and mess with all the parts. Otherwise, it'd be very, very hard to put this together. And remember, I want this to be serviceable. I want it to be relatively easy to service. Now, the good news is the new way I'm doing it, the only part that you really need to reach inside to dick with is the USB port. You're going to have to, use a pair of needles if I make the opening smaller and stick it through the hole and then glue it from behind. I got to think about that. It might also be worth having a shaft come in from this side and go through to the other side to push that USB port out the hole. Because if that glue loosens up and the port pushes itself in, you're going to have a problem with the you're gonna have to open it to get access to the USB port again. So I might want a back brace to help support that USB port, and also that will allow me to have a top brace to hold that top of the battery, so the battery doesn't try to go through the light if you drop it. Because that's the one thing I'm worried about, is this battery trying to do this, inside the flashlight, because that's heavy. But I could do that. I would still count that as the body being basically two pieces, and then you would have because there really is no reason to have this unless I can't fit the battery in from the front. I gotta think about that. Because I was thinking about putting some sort of a disc or ring inside here so that it would hold the battery in place, and pin the battery in place. But I can also use that as a backing to help support the USB port. Um, yeah, okay, that could work. I like that, and it would allow me to make the whole thing even smaller. Although, I don't want it too small. I want this to be a kitchen drawer flashlight, not a super small, because I'm going to make a small one. This is supposed to be big because, you got a gigantic battery. Okay. Yeah, can't print bottom up because then this would be an overhang. That would be bad. But then again, if I make this a plate, then this can be printed from the bottom, because then it'll just be open at the top here. So yeah, then I would, if I use the plate, I'll print from the bottom. If I'm going to have this sealed, then it'll print from this end. So it all depends on how it ends up printing out. Okay. Okay. All right, I'm going to get these parts printing. Cassandra, if you're still here, I'm going to use that transition roll. I think this is going to be a final model. It's going to look nice. I have the parts to make two flashlights, so I don't mind making two versions because I have two of these batteries and I have two of the heat sinks. Yeah, it'll be fun. It's gonna be fun. Um, yeah, you beat the living shit out of someone with this. What'd you say? Beat them to death. Especially if you make it out of TPU, because it'd be indestructible. I'm actually thinking about printing the body in clear PETG. Because if I print the body in clear PETG, you'll be able to see the lights. Whatever lights light up when you turn it on, you'll be able to see them. Okay. I'm going to start printing these parts, get a feel for how it's going to go together, because I should be able to put all this in the new print. Even though I made some mistakes when I wired this, I should be able to fit all of this into the new print and get an idea for how it's going to go together. I just won't be able to use the switch until I get the new switch in. And actually, that switch might be able to temporarily just mount in there. That 12 millimeter opening, I think, is big enough for that to pass through. so I could do it temporarily until I get the new switch in. And I also need the new JST plugs because these wires can't handle 25 watts. I like the idea of being able to charge this at 25 watts. That's pretty cool. Although you really don't need to. Who cares if it takes 7 or 8 hours to charge the thing? You know, you're only going to have to charge it once every couple of years. Then you need a loop to attach a chain to 2 of them. Why? Spin them like nunchucks? That'd be some pretty heavy nunchucks. You know, with TPU, you could make a pretty nice set of nunchucks. Just print nunchucks that are hollow, and then put, you know, standard black pipe that you buy from or wood, you know, if you want it to be a little lighter, and you can make a pretty badass set of nunchucks with some TPU. You know, they'll hurt them, but probably not kill them, depending on how much infill you use. Actually, you don't even need to do that. Just fill it with sand. Yeah, just print a TPU nunchuck and then fill it with sand. If it even needs to be filled with sand, the TPU alone might be enough. Because TPU is actually pretty dense. It's pretty heavy. All right. That's it. Let me know what you think. I'll be posting updates on the Discord, of course. Um, I'm trying to get this connection here be as nice as this connection here. But if I can get rid of this altogether, then I'll just do that. But again, the one advantage of being able to print a tail cap is that I can make the tail cap a different material than the rest of it. So I could print all of this in PETG, PLA, PIBA, you know, carbon fiber glass filled ASA, you know, whatever you want. You can use a nice, pretty material. And, matter of fact, this is you could probably print this with a big fat nozzle. It's big enough, and so you can even use silks, and it'll because if you use like a 0.8 or a 1 millimeter nozzle, you can get away with using silk filament. So you can make a really pretty flashlight, and then you just print this part and this part in TPU for shock absorption when it falls and hits the ground. Because this will shatter if it hits the ground. It's going to blow itself to a million parts if it hits the ground. That's why I want to use the TPU on the ends. But yeah, I'm happy. I like that. I like that a lot. Yeah, I was not thrilled with the jam it in there method of putting that light in there. That's why I'm going with the cap that screws in. That's just a better design in general. Okay. And remember, you can make a big one of these without having to buy this. Because remember, this is massive overkill. So for example, you could easily just put you know, 3D cell, put a 3D cell holder in here or a C cell holder if you want to go that route. As long as you're using the constant current driver, you're fine. You know, it'll bring down the current to what the LED can handle. And you could pack a fuck ton of double A's in there, put some 18650s in there. I'm gonna make a smaller version of this for 18650s. I'm gonna be designing a whole bunch of different flashlights because I love flashlights and I love these little cob emitters. They're just so freaking cool. They're just really neat little emitters. And the fact that I can get them for 20 cents a piece. No, 10 cents a piece. Yeah, these were 10 cents a piece. What? 12, 11 cents. 11 cents each. It was $2 for 20 of them, so it's 10 or 11 cents a piece. I mean, that's fucking hard to argue with. That's just freaking hard to argue with. And remember, you don't have to go with the expensive copper heat sinks. You can go with aluminum. I've already got a listing on there where it's like $9.70 for 10 of them. Um, yeah, this is cool. This is cool. Yeah, bayonets are a bit more work. I haven't practiced making bayonet connectors yet. I've done it. I have made bayonet connectors, and I do know somebody I can steal some from. Yeah, MacG made some nice bayonet connectors for his rockets. I could steal his bayonet. um, but um, but the threads are fine too. One of the reasons I like the threads is that and one of the reasons I did threading on this particular design instead of just screwing it together was because that makes a double wall. So it makes it really strong. Remember, my original plan was to have TPU threaded on both ends. And one of my concerns is that the TPU might squish and pop out because it's flexible, especially with a bayonet connection. Because I made a bayonet connector for my the Christmas light bulb. Um, so by having nice chunky threads, um, I made sure that it's not going to pop off. Make sure the TPU is not going to pop off. But it's interesting that I might be able to get rid of the threading altogether. No threads whatsoever. Have the whole entire thing. You just assemble it and put 4 screws in. That would be pretty cool. That would be pretty damn cool. If I could fit the battery in from this end, then I don't have to have this as a separate piece. I can just print a thin little TPU cap to slip over top of it. Get the shock absorption I need. That's pretty cool. We'll see. We shall see. Or just print the whole thing out of TPU. If I get it compact enough, just print the whole damn thing out of TPU, then it really will be a forever flashlight because you're never going to kill that thing. You're never going to kill it. I was even thinking about putting a these because these have a flat backside. The problem is it'll short. But although I really should do it from this side because the heat generating component in this thing is the MOSFETs. So this side's the side that needs the cooling. So I was thinking about taking another little 40 millimeter heatsink and then placing this on the heatsink and taping it down, and then also placing this on the heatsink so that this will all be heat synced. But that's I think I'm going overkill at that point where it's just unnecessary. It's just not needed. I don't think I don't have a current BOM listed out, but once I post these to printables, I will. What you need is, I showed everybody these earlier. You need a 1S lithium iron phosphate BMS. These are about $1 to $1.50 each. You need a PD trigger. So this is a USB-C PD trigger. These are about $1. You need a constant current driver. 5 of these is $2. You need the LED emitters. Just search for these 5-watt LED cob on AliExpress. You'll see 20 of them for about $1.70 to $2.20. They cost nothing. You need a 40 by 40 millimeter heatsink. A 40 by 40 by about 10 or 11 millimeters. The copper ones are about $8 a piece. The aluminum ones are 10 for $10. So $1 a piece. And then whatever lithium iron phosphate battery you want. I'm choosing this one. It's just do a search for lithium iron phosphate, 20 amp hour. And I'll create a list for these as well. I'll post it to the Discord once I finalize the list. But here's the name. That's the one I'm using, but you don't have to use one this big. You can put 3 or 4 18650s in series. You can do. I thought I heard a noise. You can do whatever you want. This is designed for a 1S configuration, but you can parallel batteries. Just charge them up first on their own so that they get balanced, and then once you put them together, they'll self-balance. You could buy 18650s dirt cheap. In fact, one of the versions we're going to make is going to take 4 18650s. I'm having trouble finding the components that I want that are lithium iron phosphate compatible. Even though lithium iron phosphate has less power density, I don't care. It'll last 20 or 30 years. That's all I care about. So my flashlight runs for 7 hours instead of 10 hours. Wow. What a sacrifice. But I'll get the bomb posted too. And then of course the switch. We got the switches, $3.70 for 10 of them. And of course, if you have stuff at home already, you can use that. I'm also using these JST connectors just because I like the idea of being able to plug and play components without having to desolder them. So by having these, just make sure you get the ones that have at least 20 gauge wire. These are too thin. Where is my can? Your cup. Those thin ones actually started to heat up when I plugged this in to charge, because this is capable of charging at 25 watts. It's a really fast charge. That's actually a lot of amps at 5 volts. That's 5 amps at 5 volts. I didn't even know this thing could do that. That is this thing pushing out that kind of power. Here. Yeah, this freaking bad boy here. This thing was pushing freaking 6 amps at 5 volts. Oh, like, damn, dude. That's a lot of juice for 5 volts. I was using that because it would tell me how much power it was drawing. Backwards text. The camera's inverted. But I'll get that all posted. I'll post pictures of the parts. In fact, I'm going to order the AliExpress parts. Let me see if I have the money. I think I do. I got $23 back from Ibotta. Yeah. And it said it was finished, so that should be in there today. That should be enough money to order the parts because they're not expensive. Come on, log into the damn account. Yes. Okay. Okay, cart. All right. I do want ring terminals, but I don't want to spend that kind of money. Let's see. Here's the switches. That's all I need, right? Yeah, I need the switches and I need the wires. Why are these $12.56? I thought these were cheaper. Oh, that's the 15 pairs. Where's the other ones? That's right, there was a shipping charge, but I didn't care because it was a nominal shipping charge. It was such a small amount that I just didn't care. Nope, we don't want that. Why don't I see everything? Why is it all mixed up? Is this the one? What the hell? I know I saved it. Is that it? Nope, that's 22. Here's silicone. Go away. On 20 centimeter. That's too much. 937 plus 5. I saw it for cheaper. Oh, maybe it was under Dollar Express. Dollar Express is a completely separate thing. Yeah, it's under Dollar Express. Okay. 20 AWG, 10 pairs, silicone wire, $5.63. Okay. In fact, I use enough of those that I'm going to get 2 sets of those. Okay. Look at this. You want to see amazing? That is a lithium-ion battery charger in BMS. You plug your little 18650 cell into that. You could fit that on the end of the 18650. What I'm looking for is I'm looking for this. That's bidirectional 20-watt USB-C PD. Why? Because then I can make a copycat of the Ryobi 1 USB batteries. Yeah. Okay, that's why they're there, because it's under that one. Okay. I just need to pick another item to... I'll just pick that one. I do want to get one of those just to play with. But they're almost too damn small to dick with. They're so friggin' tiny. I was also thinking about these, because those are 12 to 24 volt LED cob arrays, which means they will run directly off of these batteries with no additional anything needed. In fact, I think I am going to grab some of those. It's 5 of them will make a nice head. How about I start with 2? And then I could buy more if it works out well. Yeah, let's do that. Okay, that takes care of the JST plugs. I've already got the wire. Right, here is the plugs. There's the short G5, 10 pieces, 3 gear, 6 pin. It's going to be fully exposed, so that's not a problem. Oh yeah, you were getting an MRI. On. Okay, do I need anything else? Got the JSTs coming in. I could use a few more PD triggers. I only have 2 of those. Let's do a search for that. Why can't I search wherever the hell this window is? I don't know what this is. What the hell? Jesus. Oh, wait a minute. Let's clean up the cart first. There has got to be a more affordable version of that. That seems like so much money. Find similar. Here we go. All right. 20 pieces for $2. That's enough for 10. What's this one? .5 to 1. What? What am I looking at? One point. What the hell? Ouch. I heard they're loud too. What do these dimensions mean? I don't know what the fuck I'm looking at. There's the dimensions. Okay, that one's 5.2 millimeters. Okay, I need the 6.3 millimeters, and of course, that's the one that's not available. Of course, that's the one that's not available. But you know something, the 8.4 is probably going to be fine because I have 2 washers. I'm going to add that to the cart. Only $2.50. Ring terminals for the end of the battery. Okay. Then again, it's about the same price. This is $5 for 50. This is $2.50 for 25. Yeah, I bet. Oh, I need a replacement for my tablet too, since I screwed that one up. broke my plug for my tablet. And PD triggers. Go ahead and get that too. Oh, there's the aluminum heat sinks. But I don't need them. Not yet. Let's just do a search. PD trigger. Okay, there's 95 cents a piece. There's 5 of them for $3. There's 10 of them for $7. I'm going to get to 10. Because those I'll actually use a lot of. Although, no. It's actually... Ha! Ha! This is why you check! This is why you check! $7.10 for 10, or $3.31 for 5. So if you buy 2 of the $3.31, that's $6.62. I don't know why they do that. Oh, I was just showing you. Right there. See? It's $3.31 for 5 of them. But it's $7.10 for 10 of them. So it's cheaper to buy 2 of the 5-packs, because that'll be $6.62 versus $7.10. So it's literally 50 cents cheaper to buy 2 5-packs. Why do they do that? It's like, I just don't know why they do that. Ah. Oh, they're shipping. Okay, we don't want that. I'm using my phone because my computer's dogging so badly. Oh, that's not free shipping, so I don't want that. That one's free shipping, but it costs a lot more. Are you serious? You're charging $2 each for these things, you snake? Although I do not need an adjustable PD trigger. I just need one that's fixed at... Although I love the screw-on terminals. It makes it so easy to mess with. These shouldn't be this expensive. These should be $1 a piece. No, that's better. $4.36 for 5. Or $3.74 for 4. $3.74 for 4 is 86 cents each. Is it more than 86 cents to add another one? No. So that is the cheapest. And that gets me a free shipping. Okay. Because I have a few other things I want to convert to USB-C. Okay. Is that all I need? Cart, $16. Check out. That gets me PD triggers, the replacement. Oh, that's where the $5 went. The replacement cable for my tablet. I dropped it and it ripped the USB-C port right off of the goddamn cable. Like, sheared it right off. All right, that gets me the 10 switches, 25 ring connectors, replacement PD trigger cable, and my PD triggers. Okay. Yes. Oh, they want me to confirm. Yeah, it's me. Hmm. 17553. That's pretty cool. It actually interrupted the transaction mid-process, and my bank sent me a verification code to verify because I made 2 purchases on AliExpress. It's a Chinese website, so they wanted to make sure it was legitimately. Cool. Okay. That's it. Of course, I just found them cheaper. Only slightly cheaper. It's only 40 cents difference, but a pretty big difference if you're going to get a bunch of them. See, here's another case of them being fucking weird with the prices. Here's 10 of them for $8.09. Okay, so how much is 20 of them? $16, right? No. 20 of them is $17.13. So it's cheaper to buy 2 of the 10 packs. Why? Why do they do that? Why won't you let me add this to the fucking cart? There. I'm adding all the stuff to the cart too so I can create a bill of materials for you guys. All right, that's it. Um, I'm going to start slicing and printing the which is probably going to be the final version. And then once I get the parts in, I'll put all the correct parts into it. Although I'll be able to temporarily, I should be able to use this switch for now until I get the new switches. Since I use plugs, it'll all be plug and play. That's it. AliExpress is usually pretty quick, so by the end of next week I should have all these parts. And in the meantime, when I print the new body, I'll just transfer these guts to the new body, see how it works. But I think it's going to work well. All right. I will see you guys later. Be good.